I find it almost impossible to imagine. Well, actually impossible to imagine. One, just the size and scale of it. I mean, in the piece of the universe we can see, something like, roughly, 2 trillion galaxies. I mean, we haven't counted them all, but that's an estimate based on surveys of the local 2 trillion, 2,000 billion galaxies. And we're very sure that that piece that we can see is a small bit of what will be an infinite universe beyond. We don't know, actually.
Thanks to the James Webb Telescope, we've peered closer to the edge of the universe than ever before. Yet the revelations it has brought us have left scientists stunned as they shake the very foundations of fundamental physics. So, how immense is the universe, and can we ever hope to unlock all its secrets? What discoveries the James Webb Telescope has made that has left the scientist in a state of absolute disbelief? Let's dive in to find out. For ages, humans have gazed at the night sky, pondering the enormity of our universe. Is there an end to it, or does it stretch infinitely? Historically, we lacked answers to this profound question. A century ago, scientists proposed the idea that the universe had a beginning, which we now call the Big Bang. But today, the James Webb Telescope is reshaping our understanding of the cosmos. It's allowing us to peer farther back in time than ever before, capturing moments that are up to 13.5 billion years old. Consider this. The light we see has traveled for 13.5 billion years, emanating from objects that existed billions of years ago. Our view is limited by the reach of that light. If there was a time before the universe emitted light, it remains forever hidden from our scrutiny. Now, the James Webb Telescope has provided glimpses into the formation of the universe, showcasing galaxies so ancient, vast, and intricately structured that they challenge our prior cosmological assumptions. These galaxies defy conventional wisdom by their sheer existence. With the idea of a definite cosmic beginning wobbling, another question emerges. Could our universe have always existed and will continue to exist? Researchers are grappling with the notion that time may be finite only for us humans, and that our universe is so immense that its end is beyond our grasp. Professor Saul Perlmutter suggests that the simplest explanation is an infinite universe, where galaxies extend in every direction endlessly. Our exploration of space has led us to a realization of boundless wonder and endless dimensions. The universe's vastness and enormity not only overwhelm our senses, but also captivate us with its awe-inspiring beauty and diversity. Now let's delve into the mind-boggling dimensions of the universe. Scientists are currently examining a space that spans a staggering 93 billion light-years, and there appears to be no end in sight. It's essential to grasp that despite these astronomical dimensions, we're still observing only a fraction of an unimaginably vast universe, possibly just a glimpse of infinity. To truly fathom the size of 93 billion light-years, let's start with understanding what a light-year means. A light-year is the distance light travels in 1 year. 1 light-year equals 63,000 astronomical units, and an astronomical unit is the average distance between Earth and the Sun, about 149.6 million kilometers. To put it into perspective, you'd have to encircle the Earth at the equator approximately 3,729.5 times to cover a distance of 149.6 million kilometers, or make the drive from Munich to Berlin a mind-boggling 258,069 times. Now we're just considering the tiny space between the Earth and the Sun in cosmic terms. The observable universe, spanning 93 billion light-years, corresponds to a staggering 5,876,417,284 astronomical units, which is 5,876,417,284 times the distance from the Earth to the Sun. Astoundingly, scientists believe that the entire universe could be 250 times larger than what we currently perceive. These estimates are rooted in modern cosmology, particularly the concept of the observable Hubble sphere. Imagine a realm known as the observable Hubble sphere. It's the part of the universe we can see, thanks to light traveling from its inhabitants since the birth of the cosmos, the Big Bang. According to current estimates, this sphere extends to a colossal diameter of at least 23,250 trillion light-years, or a staggering 1,468 billion, 820 million, or 219 quadrillion, 735 trillion, 750 billion kilometers. It might sound mind-boggling, but hold on tight. We're about to stretch your imagination. Now let's dial it back a bit to a more relatable scale, the distance between Earth and the Sun. If a spaceship were to traverse this distance repeatedly, it would need to make the journey 1,468 billion, 820 million times to span the probable diameter of our universe. Next, let's dive into something more familiar: light, the fastest traveler in space. To travel from Earth to the Sun, light particles require a mere 8 minutes and 20 seconds. For a jaunt across our solar system, it takes about 21 hours and 20 minutes. However, the observable universe, spanning 93 billion light-years, would require an astounding 93 billion years for light to cross once. Now you're getting a glimpse of just how colossal our universe truly is. In comparison, we humans are minuscule beings in a cosmos of unimaginable proportions. To us, the Sun is a colossal fireball, and our farthest journeys have barely grazed the surface of cosmic exploration. Mars, a mere 1.5 astronomical units away, remains a formidable challenge for human travel. Probes, on the other hand, have ventured through our solar system successfully for decades, unfazed by increased radiation due to their smaller, lighter nature. Among the space pioneers are the Voyager 1 and Voyager 2 probes, launched in 1977. They'd ventured beyond our solar system's borders and are still exploring its outer reaches. However, it will take them a few more years to fully enter the immense expanse between star systems. Currently, they are approximately 23 billion kilometers away from Earth, which equals around 153.86 astronomical units, or 153.86 times the Earth-Sun distance. Both probes will take over 30 years to reach the edge of the solar system, and Voyager 1 zooms through space at around 61,000 kilometers per hour. Yet even these speeds are just a fraction of the speed of light. To illustrate the vastness of space, consider our nearest neighboring star system, Proxima Centauri. On average, it's about 4.24 light-years away. Even if we could travel at the speed of light, it would still take us 4.24 years to reach this neighboring system. In contrast, the Voyager spacecraft would require an estimated 70,000 years for the same journey. This stark difference emphasizes the immense scale of the universe and the monumental challenges of interstellar travel. And we haven't ventured far from our own sun yet. Now, imagine billions of galaxies, trillions of stars, and countless planets in this vast cosmos. Our own star system, nestled within the Milky Way, is just one among several 100 billion galaxies. The nearest galaxies to us are the Small and Large Magellanic Clouds. The Large Magellanic Cloud is estimated to house 10 billion to 30 billion stars, while the Small Magellanic Cloud contains roughly 7 billion to 10 billion stars. Thanks to the James Webb Telescope, we've peered. Our closest galactic neighbor, the Andromeda Galaxy, is a behemoth nearly double the size of the Milky Way at 220,000 light-years across. Experts speculate it may host at least 1 trillion stars. Consider this: Andromeda, one of our closest galactic neighbors, is a staggering 2,537,000 light-years away from us. Now we've touched on just 4 galaxies, but the known universe teems with at least 100 billion to 200 billion galaxies. Wrap your head around that. Our minds grapple with the vastness, especially when we ponder the spaces in between, the colossal voids, the utter nothingness. It's here that we confront the sheer challenge of exploring the universe, even if we could travel faster than light. And we should never forget that, As of yet, nobody knows for certain if our cosmos possesses an endpoint. Now let's revisit the latest revelations from the James Webb Telescope. Scientists aim to peer into the universe's dawn, the era immediately following the Big Bang. Their expectations were high. They sought the first stars, early star clusters, or galaxies that might reveal the stark differences from today's counterparts. Instead, they stumbled upon galaxies that were eerily as well-formed as contemporary ones. Spirals, disks, and spherical galaxies seem to have graced the cosmos more than 13.5 billion years ago. This discovery puts the universe's temporal origins to the test. So far, there's been no trace in the oldest light signals suggesting that the universe tapers off, akin to scrutinizing a chicken's lifespan from chicken to chick to egg. It's as if the universe has perpetually sported its present appearance. Now, with a better grasp of the cosmos' vast expanses, you can appreciate the monumental challenge that scientists face. Measuring and understanding a space of such magnitude and piecing together directions of motion and dynamics is akin to an ant trying to utilize a calculator to fathom a colossal skyscraper. So, here's a question. Does it even make sense to hunt for an end or a beginning of the cosmos? Can you fathom an infinite universe? Let us know your thoughts in the comments section.